Okay, hello everyone. Today we are learning about the quadratic formula and solving quadratics just in general. So what I want you to do right now is I want you to open up your OMG to your table of contents, and we are adding page 72 quadratic formula to your table of contents. The table of contents, remember, is page 3. And when I was walking around the other day, I noticed that quite a few people did not have theirs updated. If you need it, remember on our website, tinyurl.com/CHUHALG1, you could find our table of contents at any time, and you could fill in what you need. So, like I said, today is page 72, quadratic formula. But if you are missing 70 or 68 or whatever you might be missing, make sure you add that. Okay, so once again, we are doing page 72 today, quadratic formula. But if you need to go back and add anything you might have missed, please do that now. Okay, so we are on page 72. And today we're going to be learning about quadratic formula. It's super important. We're going to be using it all the time in Algebra 2. So you really want to make sure that you have this in your table of contents so you can find it when you're in Algebra 2.
So it is still the same learning target of I can solve quadratic equations. So once again, we have learned how to solve quadratic equations by graphing them. We have also learned by factoring them. And now we're going to learn how to do them using the quadratic formula. Before we do quadratic formula, I'm going to show you what you can do if you don't have an A, B, and a C. So basically, if you have an equation with just an A and a C, meaning you have an x squared in the problem, but you don't have a plain old x in the problem. So it's basically an x squared and a constant, a plain old number. If that's all you have, you don't have to go through the quadratic formula. There are some shortcuts you can sometimes use. So I'm going to show you the shortcut if there is no x in the problem. So we're going to start off by doing one of those, and then we're going to do the quadratic formula. I will break this into 2 videos so they're not super long because you're going to see the quadratic formula is rather long. So when we do the examples, they might take a little bit of time. So I'll probably do 2 videos. Okay, so and I'm going to pause the video and go ahead and write this information down. Pause the video, write all of this information. So the title at the top is Solve Quadratics. And these are going to be the steps if there's an x squared but no x. So there are only 2 steps. You're going to first isolate x to the second power. Remember, isolate means get it on the side of an equal sign all by itself. So get the x squared all by himself. Now, obviously, it could be an a squared or b squared or c squared or a w squared or a v squared. It doesn't really matter. You know what we mean. They can use any variable they want. And then the next step is going to be to square root each side. Pause your video, and then we're going to do the example together. Okay, ready for the example. So I'll leave our steps up there. So it says that we're going to isolate the x squared. So I nicely colored the x squared in orange. See how it's in orange? That means we have to get that on the side by itself. So if you have your equal sign, you want to get that orange x squared all alone. So you're going to use please don't call me after midnight, all of the steps that you already know how to do to get something on a side by itself. Okay, so the first step, you would take care of parentheses if you had them, but you don't. You would distribute if you had some parentheses and had to distribute, but you don't. Oh, this is prepare, not parentheses. I'm going crazy. Do you want to prepare this by doing plus negative? Boom, boom. Okay, we don't have any invisible ones. Okay, now distribute. Now combine like terms if they're on the same side. X squared and 31 are on the same side, but they are not like, so we can't put them together. Move variables. So if I happen to have x squareds on this side and x squareds on this side, I would be able to move one of them to one side or the other. But since I only have one, I'm good on that. So my second to the last step is to add or subtract the constant away from the variable. So if there's a plain number on this side, I need to get rid of it. So the plain number is not the 4, because that's a coefficient stuck on x squared. And the plain number is not the 49, because it's not on the same side as the x squared. So you don't have to move it. It is the negative 31. So how do we get rid of negative 31? Or minus 31, either way you want to think about it, you're going to plus 31 on both sides. So I'm going to add 31 to both sides of the equation. So that's going to leave me with 4x squared is equal to 49 plus 31 is 80. I'm on my last step, multiply or divide the coefficient away from the variable. So here's my variable, x squared. The only thing that is touching it, the coefficient on it, is this 4. So I have to divide the 4 out. So divide by 4, divide by 4, and I end up with x squared equals 80 divided by 4. I get 20. So I have done step 1. I have isolated the x squared. I've gotten the x squared on the side of the equal sign all by himself. There's no other numbers or anything with him. The only thing that's allowed to be with him is an invisible 1. But we can make it divisible. Okay, the next step says to square root each side. So square root means I need to take the square root of both sides. So a square root is this. So you might want to add that in your notebook. That is the square root symbol. That's called a radical. And it indicates that we should be taking the square root of a number. You'll learn next year that you can have little baby numbers on these. So I'm going to square root this side and square root this side. The cool thing about a square root is a square root and a square undo each other. So if I'm squaring something and I want this squared gone, I square root it and they kind of cancel each other out. So on this left-hand side, this square and this square root undo each other and I'm only left with x, which is what I want, right? Now this radical 20, I have to do what I have been doing with simplifying radicals. So I'm going to go off to the side and write my radical 20 because I need to take the square root, simplify radical 20. Now the first thing I would do, I would check to see if it happens to be a perfect square. So I'd probably get my calculator. If you're on Desmos, you could pop up your thing and get your radical sign and put in 20. And when I put that in, clearly this is not a perfect square. So sometimes it's perfect and I could just take the square root of it and then I would be like, oh, it's positive and negative 7 or whatever number I get here. But this is a decimal, so we are not going to write that. Instead, we're going to simplify our square root. And we do that by bringing out our list. So you have your list of perfect squares on page 92 of your notebook that you have been working with for the past couple days. So we need to get all the perfect squares that are close to that. So if you look at your list, I'm just going to put a couple of the numbers that are on the list. So you know that we had 25 was on the list, right? Because that equaled 5. The next smallest one was 16 because that equaled 4, really positive or negative 4, right? Then we had 9 because that equaled positive or negative 3. And then we had 4, which is positive or negative 2. And then the smallest one we had was 1. But we know when we divide by 1, nothing happens. So we kind of just ignore that radical 1. Kind of like how we ignore the 1 when we're talking about GCF sometimes. Okay, so what I would do is start with numbers that are close to 20. Now, you know you have a big, huge list, but you don't need all these big numbers down here because 20 is in between the 25 and the 16. So if you didn't know, you're going to start dividing things into there if you didn't know by heart what goes in. So you're going to divide the 20. I'm going to start right here. Not at 25, that's too big, but I would start with 16 in my head and be like, no, 16 does not go in evenly, so it's not 16. I would go one smaller and try the 9. And then I would also be like, nope, that does not work either. Go one smaller to the 4. And that one clearly works. Now, obviously, this is division you could probably do in your head, but check them on your calculator, whatevs. Okay, so 4 is the perfect square that goes into it. Okay, so that means that we're going to break this into the perfect square of radical 4. And my other number, remember, is what I get when I divide it. So radical 5. And I didn't take the square root of either of these numbers yet, which is why they're still under the radical. Okay, so next thing I could do is this first one will always be the perfect square because you always put it first. Whatever you took from your list is always going to be first, and it's always going to be perfect. So you can look at your list or even in your calculator. If you didn't have your list, you could put in radical 4, and you would see that that's a 2. Now, we know that's a positive or negative 2. So that's a positive or negative 2. And remember, people read that plus or minus 2, which is fine. This radical 5, it is not a perfect square on our list, nor could it be broken down if we did the first step correctly. So we're just going to bring down that radical 5. He has to stay in the radical because we did not take the square root of him. This 4 is out of the radical because we did take the square root of him. We can't take the square root of radical 5. It's not in our list. And if we checked it on our calculator, you see what happens. Yeah, don't want that. Okay, so radical 20 simplified is positive or negative 2 radical 5. And this is our answer. So what that means is if we were to graph this, it would cross the x-axis at 2 spots. The one solution is positive 2 radical 5, and the other solution is negative 2 radical 5. So I could even put that in my calculator. So I could put in positive 2 radical 5. Look, it gives me 4.4 blah, blah, blah. The other solution is negative 2 radical 5. So when you see it written like this, that means there's 2 solutions. One of them is positive and one of them is negative. So we're saying that this equation here crosses the x-axis at this spot and this spot. So if we were to graph it, that's where it would cross. And we can even graph it if we want. Let's put in 4x squared minus 31 equals 49. Look, there it is. It crosses right there and crosses right there, exactly like we just came up with. But remember, sometimes you don't get Desmos. But you can see that those are the 2 solutions. Remember, solutions are x-intercepts or zeros or roots, and there we have them. Okay, make sure you have all the information. Now remember, you can put other notes by your notes. So you can say all of those things that I said out loud. When someone talks to you about notes, you can add those in there. Like you might want to add. A good thing to add would probably be that off in the margin that this and the exponent of 2, these 2 things cancel each other out, right? So that way, when you're doing this step, you remember that. So sometimes when people talk about notes, your teacher won't always write down every single thing you ever have to know. They might write down the key notes and then say other things, but that doesn't mean you can't write extra stuff in the margins. All right. Make sure you have all of that information. Look it over and make sure it all makes sense to you, what you did. And then start the video back up. Okay, still on the same page. This is still on page 98. Sometimes you can't factor. And sometimes you have an x squared and an x and a constant, so you won't be able to do this top step. And sometimes you don't get Desmos when you take a test. So the next step is the next method of solving your quadratic is using the quadratic formula, which quadratic formula is awesome for when you can't factor, which usually means your answer might be a hot mess of a decimal. Okay, so pause your video and get your steps. Yes, you need this formula. Be very careful copying it down. So after you copy it down, refer back and make sure it's exactly perfect, because if you start using the wrong formula every single time, that is bad news. Okay, so step one, you want everything to be in standard form equal to 0. So you need to have 0 on one side of the equal sign. Standard form means highest powers first. Next, you're going to find A, B, and C. Remember that A, B, and C are just numbers, right? When we talk about those, we don't include the X's on them and all the variables. It's just numbers. Very important. Some of you guys are still trying to do ABC when you're doing your X for factoring and you're putting the X squareds on them and everything else. Remember, ABC is just the number parts. And step 3, you're going to plug it into this formula and simplify. So get this formula, X equals the opposite of B, negative parentheses B, plus or minus big giant radical over all of this stuff. Parentheses B to the second power outside, minus 4, parentheses A, parentheses C, all divided by. You see how long this divided by sign is? It's under this part and this part. So it's a whole big divided by 2A. You might also see this. We know that this could change into a plus negative if you wanted, right? Which when I do it, sometimes I change it to a plus negative. Remember, you're going to get the same answer. Okay, pause your video. Make sure you have everything perfect. The second video is going to have 2 examples.